Okay, welcome to our first asynchronous lesson of the year. We're going to be talking about functions as we started talking about in class today. So what we talked about with functions is they're predictive. They help us make predictions about what will happen in the future or what could have happened in the past given a set of data. So if I have a graph, or if I have a set of data that I can graph, right, and I see that data is following a certain path, and I can reasonably determine a function that will map that data, then from that data I can make predictions about what's going to happen in the future with future inputs, or I can go into the past and think about where past inputs could have gone. So, for example, if you're in a new area and you start tracking the deer population over time, after you have enough data, you can predict what will happen to the deer population in the future. You can plug in a certain day or time of year, and then you could reasonably predict how big the deer population will be based on your function. So we started talking about no correlation versus correlation, right? So here the data is kind of all over the grid here, and it doesn't seem to be following any kind of pattern, so we can't use this data to make any kind of prediction about other future data. But here we can see, in this case, the graph seems to be trending downwards. It's not a super strong correlation, but at the very least we can see that as we go to the right on the x-axis, it seems like the data is trending down. So think back to your food graphing that you did on the Desmos activity and how you tried to find a way to graph your food in a way that would show a correlative relationship. So we have our first 60-second question, and how this is going to work is you're just going to pause the video and silently respond to the question. So I have a nice graph here, so I want you to pause the video, read the title, read how the axes are labeled, and then just write what do you notice and wonder about this graph. So go ahead and pause the video, and then when you're done writing, you can unpause. Okay, so hopefully you had a chance to write down your thoughts about this graph, which is showing Colorado high school rankings according to U.S. News and World Report versus the percentage of economically disadvantaged students in those schools. So I pulled this from 2018-2019. So one thing you might have noticed is over here where there is a small percentage of economically disadvantaged students in these schools, there's a big cluster in the top 50 in the state, right? And then you can also see that if you go to the lower ranked schools, more in the 150 to 200 range, you don't see a lot of schools where they have a high population of economically disadvantaged students. And then similarly, in the top rankings, as you go up to the schools that have a higher percentage of economically disadvantaged students, there's less schools in that high ranking area that have the high percentage. And then as you move to the lower rankings, it seems there's more cluster with the high percentage of economically disadvantaged students. And I labeled that all very nicely here if you want to pause and read these labels a little bit more carefully. But we can see this upward trend, and then that again kind of gives us an idea of making predictions, right? Yes, there are some schools that have a high percentage of economically disadvantaged students that are also high ranking, but in general it seems to be that as the school rankings go down, this percentage of economically disadvantaged students goes up. And you should start to wonder why that might be, and we will definitely discuss that in our next live meeting. So be ready to discuss that with your classmates. Okay, and another thing we can do with data is we could, since there was so much data there, we have over 200 schools here, or 200 schools exactly. What we can do is put them in groups. So I made groups of 10. So each one of these dots represents another group of 10. So this is the top 10 schools, and then this is 11 through 20, and then this is 21 through 30. This is ranked 31 through 40, right? So I split up the 200 schools into groups of 10, and then I averaged out their population's percentage of economically disadvantaged students. And again, you can see that upward trend. Here I did it with groups of 25, so this is the top 25 ranked schools, and then their average percentage of economically disadvantaged students. Okay, this is ranked 26 through 50. Their percentage, rank 51 through 75, their percentage, and again, you can kind of see this upward trend. So again, stop and think, what are you seeing in these graphs? What information is it giving you? And be ready to discuss these graphs in our next class period. Now let's talk about functions in a more concrete sense here. So here's a function I want you to copy down. It's x cubed minus 3x squared plus 7. So how can we describe functions? Well, the basic answer is through inputs and outputs, right? So what a function does is it takes an input and it maps it to an output. Okay, so you can see here in the form of a coordinate point, we have our input 3, and then we have our output, which is 7, right? So then if you take your input and your output together, input 3, output 7, that gives you a coordinate point, right? So there's a couple different ways we can show this. We can use this notation, which is saying the function f maps 3 to the output 7, okay? So we could say, write this with me, function f maps input 3 to output 7. Okay. So another way we can say this is we can say f of 3. So we would say f of 3 if we were reading this out loud, right? And f of 3 is equal to 7, because if we look closer at this and actually do this math bit by bit, well, 3 cubed is 27 minus 3 squared is 9. What's 3 times 9? That's also 27 plus 7. Okay, so 27 minus 27 is 0 plus 7. That's going to be equal to 7, right? So the function f maps the input 3 to the output 7. And then obviously you could plug in any input you want here, and it would tell you what output goes with that input, and then we would have a nice graph. So what does the vertical line test tell us to review? Well, we see that we have a nice curve here. And the question is, what output does input 4 go with? Okay, so let's go to input 4. Well, input 4 could go up to output 2, or it could go down to negative 2. So the problem is that 4 is going to 2 different outputs. And that is a problem because functions, they map inputs to a unique output. So the problem here is that we're not going to one place. A function is supposed to be predictive, right? I'm supposed to be able to predict what output 4 is going to go to. So if it's going to 2 different places, that's a problem, and we don't have what we would define as a function. This is not a function. So that's what the vertical line test is informally telling us. If we draw a vertical line and it crosses through 2 points, that means the input is not going to a unique output. It's going to 2 different outputs. So this, what we would say, is not a function. Not a function. So it fails the vertical line test because input 4 is going to 2 different places. In fact, all the inputs, except for 0, are going to 2 different outputs, so we cannot define this as a function. Functions tell us the exact output that an input will definitely go with. All right, that's what we need to define a function. Okay, so another 60-second question. You have 7 graphs here that you might have worked with in Algebra 2. So I want you to pause the video and see if you can match each function with its correct corresponding graph. Okay, hopefully you paused and tried that out. If you haven't, then please pause the video and give it a shot. It's okay if you can't quite remember all of them. I just want to see what you can remember. And then boom, we advance to the next slide. So here is the correct function with each correct graph, right? With its correct corresponding graph. So what I want you to do is, using scrap paper, what you want to use, construction paper or just plain old line paper, that's fine. I want you to cut out little squares. And on one side of the paper, I want you to write the function. And then on the other side of the paper, I want you to draw the graph with each of the points labeled as I have them labeled here. Because I'm not a huge fan of any kind of memorization, but if you study these flashcards, you start to just automatically associate the correct graph with the correct function. That's going to make you more efficient as we start to deconstruct these functions, right? So there is a place for kind of just rehearsing and trying to get quicker at associating graphs and functions. But what I'm really more interested in is understanding why each of the functions looks this way. So that's what we'll do more extensively with each of these individually. But for now, pause the video, make your flashcards, and then when you're done making your flashcards, you can resume the video. Okay, so to finish up here, we're just going to deconstruct one of these functions, f of x equals x squared. So you should take a second to think, what do you notice about x squared? And record any notable features in your notes. Again, pause the video and do this. So what notable features do you see? Okay, so one thing you might notice is that it is symmetrical. Right? It's symmetrical because you can see a nice line of symmetry right here where it's like a perfect reflection on either side, right? So we can say this. All right. You may also notice that there is nothing going on down here, right? So what would be a mathematical way of saying that? We could say that there are no negative outputs. Okay. Okay, and just you may have noticed more things, and I'd love to hear those from you, but the last one I really want to focus on here is that you can notice that as you move away from 0, okay, moving away from 0, okay, maybe we should say from x equals 0, curve gets steeper. Okay, so you can notice that as you move away from 0, this curve in general is getting steeper on either side, right? So really quickly, we should deconstruct why those features are happening. So first of all, why is this symmetrical? Well, because, just for example, so let's do the reason in a different color. For example, negative 2 squared is the same as positive 2 squared, right? Negative 3 squared is the same as positive 3 squared, right? So if we look at this symmetrically, input 2 goes to the same output as negative 2. 2 squared is 4, negative 2 squared is 4. 1 squared is 1, negative 1 squared is 1, right? So that's going to create a symmetrical graph. Okay. Why are there no negative outputs? Think about that for a second. Okay, well, what happens if I square a positive number, and I'm just going to denote a positive number with a plus sign? What happens if I square that? What kind of output do I get? Get a positive, okay? And then I'll denote a negative number with a negative sign. What happens if I square a negative number? Well, that also gives me a positive, okay? There's no way to possibly get a negative output because 0 squared is 0, a positive squared is positive, and a negative squared is also positive, okay? Now, last thing to deconstruct here is moving away from x equals 0, why does the curve get steeper? Okay, so let's think about it like this. Let's think about the outputs, because the inputs, let's just say we're looking at inputs going up by 1, right? 0, 1 squared, 2 squared. Next would be 3 squared is 9, right? So let's look at the outputs, okay? So we have inputs and we have outputs. We have input 1, 2, 3, 4, okay? And then let's list out our counting numbers in the output category too. Okay, I'm just going to magically make this appear. One sec. Okay, so let's start with input 1. Okay, where does input 1 go? Well, 1 squared is equal to 1, right? So, right, 1 squared is 1. 1 squared equals 1. Okay. Input 2, where does that go? Well, 2 squared is 4, right? 2 squared equals 4. Okay. What about input 3? Where does that go? Well, that goes all the way over here to 9. So 3 squared equals 9. Okay, what about input 4? Input 4 goes all the way over here to output 16, because 4 squared equals 16. So what you should notice is, as we are increasing our inputs by 1, our outputs are getting more spread out, right? So as we increase our inputs by 1, our outputs are becoming more spread out, which is creating a steeper function. So what we should write here is we should say, as run, quote unquote, for inputs increases by 1, our rise, quote unquote, is becoming more spread out. Okay, and you can see then as we make our rise become more spread out, you can see how that would make a more steep function like x squared is becoming. Okay, so you may want to look over that portion of this lesson a couple times, just make sure you fully understand all of those reasons. Okay, so for your closure, I just want you to take 5 minutes to study your function flashcards so you can start to associate the correct graphs with their corresponding functions. And that is all I have for you in this video. I'll see you in our next class.